Hello, all. So let's start with a very important topic for coding interviews, which is dynamic programming. So I will cover this topic along with the problems in few set of videos. So this is the very first lecture. So let's dive in. Why dynamic programming? Like, firstly, what is the need of dynamic programming, right? So let's do that. So we also already know that some of these famous problems are. If you don't know, that's fine. That coin change, like return number of coins, minimum number of coins to make amount 10 or make given this. So let's say we have some amount coins like 2, 5 and 1, right? And make the amount 12 using, and the constraint is just use the minimum number of coins. So what can we do for such a purpose? Then house robber, like we have to rob the houses given some constraint, right? How can you maximize the robbery? Okay, that, so something like this. Okay, so all these problems are under this category. But firstly, how can we identify that this is the problem of dynamic programming? So let's not go to the problems right now, but let's just make the intuition that how to conclude that this is a problem that can be solved with dynamic programming. Okay, so when to use dynamic programming, let's do that first. Okay, and then we will consider why dynamic programming. Okay, so for example, we know that our recursion, right? So we know that there are a lot of recursive calls. So very famous example for recursion is a Fibonacci sequence. And we know that what is Fibonacci sequence? Like first two sequence are 0 and 1, and then rest are the addition of previous two. So 2, so sorry, this will be 1 again. So 0 plus 1 is 1. Then 1 plus 2 is 3, right? 1 plus 1 is 2. Then 1 plus 2 is 3. Then 3 plus 2 is 5, and so on. So this goes like this. This is the Fibonacci sequence. And we all know this, right? And we also know that how to solve this using a basic recursion. This we have done in our undergrads as well, or even school as well, that we are when we are learning C. So we know that when it's either 0 or 1, right, then we will return the same number, whatever it is, either 1 or 0. But if it's not, then we will go 2 steps backward from that n. So if I draw something called as how many recursive calls are there, you will see that there will be so many unnecessary recursive calls. Let's see what is unnecessary. For example, let's say I'm just calling this function fib, okay, just for space constraints. Here I don't have space. So if I call this function just fib and just pass 6 in it, then we know that it won't go into this if condition because 6 is greater than, not less than or equals to 1. So we will go into the else condition and we will call the same function again, which is 4 and 5, right? Or 5 and 4, doesn't matter, whatever you can write. So now again 4 will call itself, so it will be 2 and 3, we know this, and 5 will call itself, which will be 3 and 4, and this continues, right? Like for example, here it will continue fib 1 and fib 2. Here as well it will continue fib 1 and fib 2, just writing 2. Okay, but now if you will notice, and if we can expand this further, okay, but if you will notice that this fib 3 and this fib 3, like if we calculate the value of fib 3, then we don't have to calculate for here, right? So in short, if we calculate fib 3 before, and if we encounter fib 3 again somewhere else, right, why can't we just use that value so that we can skip those recursive calls? Because you know that this recursive calls will be like so many, right? For bigger number like 100 or 500 or something, we will be having a lot of recursive calls, and there will be a lot of such problems, and such problems are called overlapping subproblems. You might have heard about this, if not, and that's where dynamic programming is used. And that's why the name can be debatable, that why it's just named dynamic, can be a good name as well. But why it's called dynamic? Because we are using dynamically this value to somewhere else, and even in future somewhere else, here as well we will be having fib 3 and fib 2, right, in 4. So we can use there as well. So we can avoid calculating all those recursive calls by storing this value when we encounter it first. And why can't we just simply use it there? when it's needed. And that's what dynamic programming is, and that is where it is being used. So, and those problems are called overlapping subproblems. So, as I said, the main culprit is recursion. If we do this recursively, you will see that for bigger number, it will expand, like this tree will expand like exponentially, and it will be 2 raised to n. So the time complexity will be O of n, where n is our number, right? If you will expand it, it will expand, so on. But you will see that there will be a lot of such problems which will be occurring. And those problems are called overlapping subproblems. So the problems where we find such overlapping subproblems, we use dynamic programming. Okay, and these are those problems. But how can we conclude that these problems are overlapping will have overlapping subproblems, or this problem will be solved with recursion? Firstly, we have to conclude ourselves that, right, when to go to the recursion. And this is where greedy comes in. Let's take the example of coin change. Okay, so greedy is what? As the name suggests, we are all greedy. What we need is, whatever we need, we go to that thing, right? We try to find some shortcut to go there because of our greed. Like, for example, we have greed for money. We find to we try to find some shortcuts, right? And that's why the name is greedy. Let's take the coin change example. Let's say we have 3 coins and we have to make amount 11. So in how many number of ways you can do this if you want to do? As a simple example, we can simply say that we will take the maximum coin, so that, because we need minimum coins, right? Minimum coins needed is what we have to find in this problem, right? And please note that each coin can be used unlimited number of times. In this problem, if you will see on LeetCode, it's given. So each coin can be used unlimited times. So if we go for greedy, right, then we know that we will take the max denomination first. Then again, we know that 5, 5 and 1 will be perfect. So greedy works in this case. But will it work always? There might be some problem where it will work always. But what if, let's say I have 2 and 5, just 2 coins, and I have to make 6. So now, if I'll follow the process of choosing the max value coin, we are stuck here. But we know that using 2, 3 times will make it 6, right? So we need 3 coins. But here, the method of greediness, that to go towards our answer, right? This choosing this max value will not always work. Even though it worked on this example, it didn't work on the very next example, right? So you can find those edge cases where greedy fails. So whenever we have problems like this, like find minimum number of coins, or find the maximum robbery, or best time to buy or sell the stocks, or like painting the house and so on. So all these problems, first try to go for greedy. Okay, don't directly jump in with the dynamic programming that, okay, this is a dynamic programming problem. No, go for greedy. So step 1 is go for greedy, and it will work. Okay, you have to find those problems where greedy works. Just search on LeetCode the greedy based problems, you will find, and then compare it with the coin chain. You will find that, okay, that this is the problem that can be solved with greedy, and this is the problem that can't be solved with greedy. Okay, so first step is go for greedy. Then if this doesn't work, if the greedy doesn't work, then go for the dynamic programming approach. But even don't jump directly to dynamic programming. Go for recursion. Go for the exhaustive approach, you can say. That just exhaust yourself by expanding this tree, and that's why it's called exhaustive approach. And you will not directly find whether it's a dynamic programming problem or not, because first step is to go for this recursive approach. In this recursive approach, we will see that, okay, there are some overlapping subproblems, and that is why we are going for dynamic programming. So step 2 is go for recursion, or I can say exhaustive approach. And of course, we know that its time complexity will be exponential. Let's say 2 power something, 2 power n, for example. But it will be exponential. And if you are done with second step, And if you find overlapping subproblems like we find in that Fibonacci sequence, even if you will expand this coin change problem, you will also find overlapping subproblems. But I won't do it in this video. It will be too much. Okay, but the very next video of ours will be the coin change problem. Okay, where we will expand this entire tree. So we will firstly go for greedy, which we already did. So we will start with this exhaustive approach of recursion, and we will identify the overlapping subproblems. And that is where we conclude that, okay, now it's time to go for dynamic programming. And we will see how dynamic programming works. Okay, that obviously now I told you the main story, that we will store the result of this, okay, somewhere. We have to store somewhere and then use it. Okay, so we will see, just we have to now see how to store that result and use it. Okay, so there are two methods, which is memoization, like it's a memorization at the end, but I don't know why it's named like this, memoization, but people call it memoization anyways. And the second thing is the tabular method, where we will store in the table form. Okay, so these are the two methods we will see. So we will see both of them. Okay, so don't worry. And it's so simple and easy, so nothing to worry about dynamic programming. But as I said, firstly, don't directly jump to, like, don't just mug up that, okay, this is the problem of maximizing or minimizing, so let me try dynamic programming. No, go for greedy approach first. If greedy fails somewhere, but you have to think of those cases where greedy fails. If greedy fails, then go for exhaustive. And in that exhaustive, you will identify overlapping subproblems, and thus we conclude that this is a dynamic programming problem. Okay, so that's it about this video. The very next video is coming on coin change. Okay, which will be a very detailed one. Thank you.